So, good evening, all of you. Today, I am going to talk about the importance of RC time constant for the environment, ESD, ESD kind of environment. So, we all know that electrostatic charge and how to discharge. Anything that is abrupt will create a problem. So, for that, what I try to convince is electrostatic discharge. So, when two materials rub against each other, one gains electrons and the other is deficient with electrons, or I can say it is more positive, the other one is more negative. So, this will create a static electricity. So, when there is a chance of discharging this static electricity, you should see that it's a smooth charge. If it is going to be abrupt charge, then heavy current will flow and it will damage the PCB. So the idea is the time constant is important. So we all know that tau is approximately equal to RCR into C. So in the human body model, we all know that the capacitance to the ground and to our legs with shoes is roughly say 50 picofarad to 100 picofarad. Similarly here also. Or when we touch against a wall, so this will range from 50 to 100 picofarad. Okay. So the range is when we touch against something, there is a capacitance which is roughly ranges from 50 to 100 picofarad. Similarly, when we wear a footwear or slippers or with barefoot, so between our foot and the ground is 50 picofarad to 100 picofarad. So, if you fix tau to be say 100 nanosecond, 100 nanosecond. So what should be the value for R? So R is equal to tau. Tau is 100 nanosecond. Nano is 10 power minus 9. And we will assume that it is having a 100, say we can have 50 picofarad, or it ranges from 50 to 100 picofarad. If I take 100 picofarad, which is 10 power minus 12. So R is equal to tau by C. So 100 picofarad. So these two will get cancelled. So R is equal to, this will go to the numerator. So 10 power 12 into 10 power minus 9. So R will be roughly 10 power 12 into 10 power 9 will give you 10 power 3. So that is 1 kilo. Okay. So if R is equal to 1K, that is 1 into 10 power 3, and C is equal to say 100 microfarad, 100 picofarad, which is 10 power minus 12. So put together 10 power 3 and 100 will give you 10 power 5 into 10 power minus 12. So this can be split into 10 power 5 into 10 power minus 9 into 10 power minus 3. So this will give 10 square, which is 100 nanosecond. So if you give this time, then there will be a smooth discharge. So for this case, for example, if you consider R to be, say R to be 10 power 9 ohms, this is R value, and C is 100 picofarad. Pico is 10 power minus 12. So 10 power 9 here 10 square, so 10 power 11 into 10 power minus 12. So this will give you 10 power minus 1, which is equal to 0.1 second. So it will be discharging in 0.1 second. So the idea is, if you make R is equal to 0, that means if you don't wear proper PPEs, personal protective equipments, or ESD protective gear, hand gloves, everything ESD shoes, ESD apron. So generally they specify R and C. R value will be roughly in maximum it can be 10 power 9 ohms. Now the question is, if this value is going to be 0 ohms, then in that case tau is equal to 0 seconds. That means within no time it has to discharge. Whatever charge we have accumulated, that has to discharge within no time. So that will cause, suppose if we handle a PCB with bare hand, then the PCB, the static electricity will pass through our hands and it is likely to damage the PCB. That's why we have to see that the discharge time, that is tau, should be anywhere between 70 to 100 nanoseconds. That is a good timing for discharge. You cannot make tau to be very large or tau to be 0. Both the cases are dangerous for ESD kind of environment. Thanks for watching this video. Nandri.